Hey, my name is Matt Zinn, and today I'm going to give you a guided tour of our ATC cabinet to highlight some of its features and benefits. You're watching this video probably because you're interested in the ATC cabinet. You're either heard about it or somebody has told you about it, and you're wondering if it's what you need for your agency. So let's go through the ATC cabinet. Let's look at the differences between ATC and NEMA and ATC and Caltrans. Let's talk a little bit about the costs. Let's talk a little bit about the safety features and the troubleshooting. But first of all, let's go ahead and talk about what is in this cabinet versus what is in a NEMA and a Caltrans cabinet. As you can see, it kind of looks like a Caltrans cabinet because the ATC standard based its cabinet functionality on the Caltrans 33X cabinet. So very similar in architecture as the Caltrans cabinet. Definitely looks different than the NEMA cabinet, but the functionality that is provided through the SDLC communications in this cabinet came from the NEMA world. So we took the best of both NEMA and Caltrans and melded them together to make the ATC cabinet. The ATC standard is 5301. You can look those up and figure out exactly what the standard is designed for, but mostly it is a functional spec. So how this cabinet works the same in any ATC cabinet. It may look a little bit different in other manufacturers, but basically an ATC is an ATC in the functional spec. So this is our ATC cabinet. This is a 352 cabinet, 352i. We'll go through the different components right now. We'll start at the top. We have a functionality in this cabinet called an ADU. This component basically is part of the CMU function. It provides the same information that a NEMA MMU216LE would provide with all the different channel outputs of where the cabinet is at any state. It also provides the help menu and the display for when we are troubleshooting the cabinet. So this is a very important part of the cabinet. If you're going to buy ATC, you want to make sure that you have one of these in every one of your cabinets because this is really the troubleshooting tool. The next part we're going to talk about is the controller. Obviously, everybody knows what a controller looks like. This is an ATC controller. It does have the ports on the back instead of on the front, similar to a Caltrans controller. There are also additional ports on the front, similar to NEMA controllers, but most of the stuff is on the back. Controller runs the cabinet. The next thing we're looking at is our input file. The input file is basically a detector rack. This is a standard detector rack and uses standard detectors familiar to both Caltrans and NEMA users. So any detector you currently have would operate in this rack. We have up to 128 channels of detection. So as you need more detection, you just add additional racks. We also have a different model of detector racks that use high density detectors. The high density detectors are 4-channel detectors instead of 2-channel detectors, and we can actually get 48 channels of detection in one rack. The next section is our output file. Basically, this is the same as a load switch. The load switches are different in this cabinet versus Caltrans and NEMA. In Caltrans and NEMA, the load switches or switch packs were the same thing. We're a single channel, and they ran on 10 amps, and they just had a red, yellow, and green. With these, we are actually running 2 channels. So there's 2 reds, 2 yellows, and 2 greens for channel 1 and channel 2. But the major difference is we can only run 1 amp per channel. That means this cabinet can only run on LEDs. We have this rack here, which is 16 channels. We can put up to 32 channels in an ATC cabinet. So we would actually have another output file if we were running the 32 channels. The next component of this cabinet is our service assembly. This is where the AC comes into the cabinet and then is dispersed to the rest of the cabinet. It's filtered, it's noise protected, and it's surge suppressed. And it does it all here. We actually have all of our circuit breakers as well here. So in any of the circuit breakers that turn on master power and controller power and output file power is all located here. We also have the flasher. Because we've decoupled the flasher from the cabinet and it's in the service assembly, if we need to replace any of these components that I've talked about so far, we can do that without putting the intersection into a dark condition because we keep the intersection in flash because the flashers are here. We also fuse our flasher outputs We also provide spare fuses for those fuses in case something happens with the flasher outputs. The rest of the rack is pretty much just for use for whatever you want to use it for. Battery backup systems, communications, additional detection systems that aren't using the rack mount can all be mounted right in this area here. You've got your ATC cabinet, you're going to test it. How do you test it? Well, we do have a test display you can purchase, and basically it comes in multiple different versions. We have a 16 channel that you see down here at the bottom. We can make a 32 channel test display. We can also make a test display that has the ability to test for conflicts, dual indications, and red fails. So they have little toggle switches that you can use to select a red fail or a dual indication. So all these different test displays that we have are additional to the cabinet itself, but definitely necessary for testing this cabinet. A major difference with the ATC cabinet versus NEMA and Caltrans is the way we troubleshoot the cabinet. This cabinet is a lot easier to troubleshoot than either the NEMA or the Caltrans cabinet in several ways. First of all, the ADU that we talked about will actually show us where to start looking for the problems. So you open up a cabinet door, something has failed in the intersection, you get to see these blue lights right here. These blue lights basically tell us where to start looking for the problems. Right now, the blue lights are on channels 5 and 6. So I'd have to go down and look at my output assembly for channels 5 and 6 and figure out what the problem is. Maybe it's just, as this is, a loose load switch or high density switch pack. Plug it back in, problem's resolved. Goes back to normal operations. We also have this menu over here that we can walk through. It's a help menu. If we see the blue lights here, we can hit the help button and it'll tell us exactly where the problem is. It'll tell us what the problem is. It will define the problem, and then it will tell us where to go look for a solution. So it's pretty much done most of the legwork for us in a troubleshooting issue. So even new users of this system find that much easier to work on. Other than that, it is still a traffic signal cabinet. So it still operates like a traffic signal cabinet, and you would still do the same troubleshooting for any issue that doesn't show up here correctly. One of the questions we get is, how much does this cost? Is it more expensive than a NEMA or a Caltrans cabinet? Up front, it's a little bit more expensive. So the same capabilities in a NEMA cabinet or the same capabilities in a Caltrans cabinet will run you a little bit less. Really, the biggest cost difference is the load switches or the high density switch packs. They are considerably more in cost than the old traditional load switches were. However, because this cabinet is much more reliable and will not require as many call outs in most cases than the old NEMA and the Caltrans cabinets have, your total cost of ownership actually goes down because you're not spending all that time rolling a bucket truck. And we all know how expensive a bucket truck costs. We're not rolling bucket trucks to go out and fix things in this cabinet. Or if we do, the amount of time spent troubleshooting this cabinet is less because we have this exceptional troubleshooting tool in this cabinet that is not in a NEMA or a Caltrans cabinet. It's a much more reliable cabinet because it's not prone to electrical variances and shocks and other types of things that would cause problems in a NEMA or a Caltrans cabinet. So again, much more robust. One of the things that the ATC cabinet is known for is its touch safe capabilities. Basically, a NEMA cabinet and a Caltrans cabinet has tons of exposure for AC, live 120 volt AC. It's very easy to get tagged in a Caltrans or a NEMA cabinet. In this cabinet, there is absolutely no exposed AC. I can put my hand anywhere in this cabinet, anywhere, without fear of having AC exposed. So I'm not going to get shocked. I'm not going to get tagged for any type of AC. That is the number one safety feature for the technicians in this cabinet, is to be protected against live AC. In Caltrans world, they are required to wear arc suits. And in some instances, because it's a touch safe cabinet, they don't have to do that anymore. So we talked about the front of the cabinet. Now let's look at the back of the cabinet. As you can see, the back of the cabinet is very clean. Unlike a Caltrans cabinet or a NEMA cabinet, which everything is pretty much hardwired onto back panels, everything here is nice and clean. There are no additional wires or anything that can be seen because we run races up the sides of the cabinet to make sure everything in this cabinet is very clean. All of our panels also have races across so that we can wire up our wires nice and clean. This is a very clean cabinet. So let's take a look at the back side of the cabinet. First of all, we have our power supply. Power supply is a 48 volt, 24 volt power supply. So it provides 24 volts and 48 volts to the cabinet as needed. We also have our DC and power supply and serial connector panel. Basically, every device in this cabinet is serially connected. So our CMU is connected that way. Our detector inputs are connected that way. Our outputs are connected that way. And so is our controller. So you'll see that we have different connectors for each of the devices in our cabinet. We also have power going to each one of those panels. If you're going to replace anything, it really just requires unscrewing that panel, pulling it out, disconnecting 2 cables, plugging in new cables, and now you've replaced the product. So very easy to troubleshoot that way. We also have a clean power bus. The clean power bus is basically anything that requires AC is plugged into this. If it's in a cabinet for communications, if it's in the cabinet for control, if it's in the cabinet for detection, we plug it into here. We do not plug in fans or drills or vacuum cleaners into this because this is clean power. We're only using it for electronics. This is our field input terminal assembly. This is where we would wire in our loops. This is where we wire in our preemption. This is where we wire in our push buttons. And any input can be used for any of those. So unlike a Caltrans or a NEMA cabinet where specific inputs were used for preemption and specific inputs were used for PEDs, it's no longer required in this cabinet. This is our field output terminal assembly, or sometimes called a FOTA. And this is all the field terminals. This is the red, yellows, and greens going out to the fields. On this panel, you'll also notice that we also have our flash transfer relays. Flash transfer relays are much smaller than you're used to seeing, and they are also metal, and they're hermetically sealed. So it provides a better solution to the old plexiglass flash transfer relays. And the last thing on this panel that you'll notice is we have these flash blocks, these little red, yellow, or white flash blocks. This is how we determine how the intersection is flashed during a flash condition. Below that, you see the backside of our power distribution assembly. The backside is where we bring in the wires from a service assembly or a service meter pedestal to provide the AC to the cabinet. It's also pre-wired for battery backup systems. So no more extra plumbing for wiring up battery backup systems. These cabinets are all ready to go in for battery backup systems. All right, so that's the back of the cabinet. Like the NEMA and the Caltrans cabinet, pretty much the same functionality, just arranged a little bit differently. We still have our detector inputs and our field outputs. Thanks for watching this video. Stay tuned for more videos like this in the future as we address some of your frequently asked questions. To learn more, or if you have any other questions, please visit the Swarco McCain website.